So here's our fishing derby, and we've reached the point in the driver class where we can do most of the basics. We can make some fish and make some buckets and add the fish and get people to go catch fish, and eventually at some point when the derby ends we can pick out who won and we can print out information about them and their biggest fish. So the only thing that's really left to get this in a sort of a working application is to do a couple of printouts of information that people are going to want at the end. And so the first thing that they're going to want is to see the order of the winners. So print out the placements. So first, second, third, fourth, etc. Okay. So what you would like to do is you would like to say for each bucket in the derby, which is registration desk, get the biggest fish, from whatever that bucket happens to be. So retrieve the biggest fish from the bucket and then print out the information about whose fish it was and what size it was, right? So that would be a bucket dot get first name plus a bucket dot get last name. And I'm just going to cheat here and just print out biggest fish dot get weight, and we'll add a print statement up here to say what we're printing out. Something along that line. And now when we go and look at the error says, no, you can't run a for each on buckets. But what can you do? It says buckets need to be, or the registration desk in this case needs to be iterable. So we'll go into the derby class and we'll say, okay, if you want to be iterable, we'll just say you're iterable. And the thing that you're iterable for is all of the things that you're storing. So in this case, it's bucket. And then it says, oh, no, sorry. You promised, but you didn't fulfill your promise. And so there's an empty promise. Doesn't do anything useful, but hey, I said I would. So now the trick here is, well, I don't have an iterator, but I know that all buckets does. So I'll return all buckets dot iterator, and then we go look in the driver, and now all of a sudden that's happy. And so hopefully when I print them out, I get them in what order? Any guesses?
Order they were added?
Currently, just the order that they were added because didn't sort them. So we'll go back into where we did our iterator, and we'll add collections.sort. Oops. to sort the buckets. What order are we going to get buckets sorted by?
Smallest to biggest.
Smallest to biggest, because
That's how the compare to works.
that's how the compare to works. So buckets are sorted, in this case, by whatever the compare to says. So it's a trick question, because the answer is compare to defines the order, and in this case it's the order of fish, and fish are done by their compare to, which is by, I can find fish, by weight. Okay, so the bottom line is it's by weight. So trick question, sorting always occurs by whatever the compare to order is. Okay, so we'll go back and we'll run that thing. And now we get them sorted by weight, but what order do you actually want them in?
Biggest to smallest.
Other way around. So we'll go back into our Derby class and we'll just flip the order here after we've done it with collections.reverse. And now we'll get them in the right order. Okay, so we could put first, second, third, fourth if you wanted to on that, but there we go. Okay. By the way, iterators, if you go look at what the documentation says, the promise for an iterator is just that it will give you back all of the things that were available. It's actually not that it will give them back in any order. Okay, so we're sort of cheating a little bit here to put an order in and tell people you can presume what an order is, because that's really not what an iterator promises, but oh well, close enough. Okay, so now we've got the driver, so it will go through and print out all the placements. What if I want to go through and print them alphabetically? So I'm just going to steal all of this code again, and I'm going to say alphabetical. And I better change my comment, which people always forget to do. So now how are we going to make that happen?
Do you need another compare to?
Yeah, we can't use the existing compare to because it's incorrect, so we have to write another compare to. So what's the thing that you're trying to put in order?
The owner's name.
The owner's name in the bucket class. So bucket is the thing that needs an alternate sorting method. Okay, so there's the default order for buckets is by fish weight, and we'll have to write a different one. So this is the point where you go digging for your weird syntax for these things and steal one from elsewhere, or you can try to write them off the top of your head. This is the one that uses a comparator only for buckets, which would be by last name, first name. So that's the name of the method, and all it has in it is a return new comparator so that's actually the interface only for buckets, constructor, semicolon at the end of the return statement, and then the thing that a comparator requires, other than import, is one method, and the method has got a compare in it that compares bucket A against bucket B. Okay? So it's that third party idea that you give the third party two buckets and say you figure out what the difference is. And so now we'll just resort to our sort of standard template here, is I'll go get, it's going to be the first names, or sorry, the last names compared first. So we'll go, we've got A's last name, compared to B's last name. Okay, and if they're the difference between them is that, and if for some reason they're already different, then we can send back that difference. Semicolon there. Otherwise, the difference is first names and in this case I'm just going to send back the difference because I'm done at this point. Got no choice. And that one goes away. And run source format to make it nice and pretty. And you're left with something that looks roughly like that. Okay? And the easiest way to, anytime you see these things, since they all have a standard format, you can just glance over the format and go, oh, this comparator does things by last name and then by first name. Okay? Just read off the fields and that's pretty much the order that you're going to get. Okay, so there's the thing that will do the comparison. Now the question is, how do you use it?
You have to call the comparator by last name, first name.
You have to use one of these comparators where?
It'll be in Derby, won't it? You'll call the method.
Okay. Bucket is the thing that does the comparison. You got to move up a level to get the thing that's holding on to a bunch of buckets, because it's the thing that's interested in putting them in order. Okay, so we're going to advance up a level and we're going to say, oh, the Derby class is the one that needs to do the work, and let's just write public void anything here for a moment, just so that we can get a method, and we say, oh, okay, we need a method that's going to do the work of putting those buckets in order. So what's it going to do to put the buckets in order?
Call by last name, first name.
It's going to call, where's it going to use by last name, first name thing that we just wrote?
Second parameter and sort.
Second parameter and sort. So it's going to be collections.sort, just like the previous iterator. I want to sort all buckets, but this time I want to sort it by bucket dot, and oh look, it will just give you the name of the thing that will do the sorting. Okay, so that would get all buckets sorted in the appropriate way. Now what do you want to do with them?
Return the iterator.
You can return the iterator.
You return the list with the buckets, all buckets.
Well, there's a couple of choices here. You can, the problem with returning the, well, there's two ways you can write this. Now the question becomes, what's this going to be? One way is to say, well, we'll return the iterator for buckets, which would mean that what you would send back is return all buckets dot iterator. But if you do that, if we call this iterator by last name, for instance. Then when you go to use it, you can't use a for each to do it, because that thing is really registration desk dot iterator is the only thing that's being written for you. Okay, so there's a little trick here. Is instead of returning the iterator, what you can do is you can say, well, what I'll do is I'll give you the list back. Okay, and if I gave you the list back, this would just be all buckets. And then this thing would be registration desk dot iterator by last name. Or just, if you just want to shorten it, after we get it to work, we'll shorten it. So let's just run that. And there's alphabetical as Flintstone, followed by Wilma Flintstone, followed by Rubble. If you want to hide the fact that it's an iterator at all, we can go into this thing and we can change that name. Instead of calling it iterator by last name,
Control-Shift-R.
We could just refactor, rename, and call it just by last name, for instance. And let's just look and see what that does in the driver. So it's registration desk by last name to go through and get all the stuff.
It's kind of ironic that it's the same order.
Yeah. You can play with this thing and change the order if you want to see it. Okay. So there's the trick, and now we've got an alternate sort done. Okay. So all of a sudden we have a basically working application, except that what we've done here is sort of a running commentary of the fishing derby and all the stuff that's happening in the main program. It's not really useful as, oh, get user input and all of that sort of stuff. We've just run through the whole derby by hand, basically. By the way, that's known as a use case, because it was just running it through one set of things as if you were actually using the thing, which is another convenient way of testing something. To just say, well, I'm going to put it through its paces in the standard order that I would expect things to occur, and oh, look, it produces the correct stuff. Okay, so that's essentially testing by a specific use case. Okay. But unfortunately, showing this to your mom, she might be somewhat amused, but she won't be like astounded. And so I have another version here, which if we go look at the source is basically the same thing. By the way, I'm just going to remove that. I'll explain why in a moment. If we go and look at the source for Visual Fish here, notice it's still got a fish class, it's still got a derby class. This one's a little older version of the source code that I wrote way back when, so instead of calling a bucket, I called it a fisher, but it's the same thing. The fisher is holding on to a whole bunch of fish. And there's this thing here called driver GUI, which has got almost nothing in it, but that's the thing that fires up the program. Get ready to ooh-ah. Now, a couple of words about this. This is done with the Java GUI, which is the thing that you would use if you were writing standalone Java programs. Well, guess what? Nobody writes standalone Java programs anymore. It just doesn't happen. The web is the thing where everything's done. Okay? So it's in that sense, it's not the best example, except that it turns out that GUI code, more or less wherever you see it these days, looks sort of the same, so a lot of the concepts are the same. So we'll go take a peek in the code afterwards. It's not code that you have to understand how it works. I'm just trying to make the connection between the stuff we're writing and the sort of the visual world of things so that you see how all of this stuff fits. Okay? And the other thing is don't think this is a shining example of how to write nice Java GUI code. I was in a hurry and just sort of made it work. Okay? So it's maybe not the prettiest of code. So I divided this thing up into 3 tabs, one for each of the 3 phases of the thing. So what I can do is I can start out and I can register as many fishers as I want. Oops. So there's a bunch of people who've now registered for the Derby. And then if you click over on the tab, you get the fishing portion of the Derby. So this is where people are bringing in their fish, right? And so you pick the name of the person that you want out of the Derby. So Fred, you pick the size of his fish, and then you say add a fish, and it shows the current winner. Guess where the code is getting current winner from? Right? It's the stuff we already wrote. All that it's doing is just taking that information and displaying it into the GUI instead of printing it out. Okay? So there's a field that does that, and I put that nice thing there just to show you, wow, isn't that exciting? By the way, this answers the question, why wasn't I all that concerned about names and things and doing error checks for whether or not it was a valid person in the Derby when they came back and added their fish, right? I didn't worry about me misspelling things when I made the fake one. It's because I'm only allowing people to pick one that will work. Okay, so in the modern world, you don't necessarily see a lot of error checking in the lowest level of programs anymore, because all that the programs do is prevent people from making errors at the highest level by not giving them any choices. They can't make a mistake here. They have to pick somebody who's actually entered in the Derby. Okay, so that's why we didn't do a lot of error checking. Oh, what if I don't find somebody? Just doesn't matter. Okay. So people go and they catch their fish, so we'll just give a bunch of people some fish here, whatever it happens to be. Wilma catches a fish. I should make sure that everybody catches a fish, just in case I had some sort of weird error in there. So Barney catches a fish, so Barney's now the current winner. And then at any time you can plop over to all fishers, and it shows the list of people who are currently in the Derby along with their biggest fish. And I don't think I sorted this in any particular order. It's just an arbitrary list, but you could add the sort to it to get it to work.
It's in the same order you added them.
Yeah, it might be in the same order I added them probably, but nothing that a quick sort wouldn't fix. Okay? And I think it may even be smart enough that if you go back and add somebody else, that they'll, oh look, it shows up in the list of fishers with no fish. Okay, so all of that stuff sort of magically gets done, and oh look, Bam Bam now gets populated in the correct place there, so we'll give Bam Bam some sort of fish.
It's interesting, that is alphabetical.
Yeah. I think I might have made one of these alphabetical on purpose. I might have sorted this one just to show people an alternate sort or something in the code. Can't remember. We'll go look at the code. Okay. So I just want to do a quick scan of the code here for a second. So all that the main program does is it really just kicks off the GUI by saying make the frame, and the frame is the thing that has the closed box and all of that sort of good stuff in it. Okay. The real work is done in this thing called Derby frame. Oops, wrong one. And you can see the use of extends JFrame. So what this is the default one that does all this work. This is sort of like, the difference is that implements just says nothing was made for you. Extends is somebody's already written a bunch of code for you that you can use and you're adding to it. So I'm adding to existing GUI code that's in the frame. And what I've done is, oh look, there's the Derby variable, right? And there's a bunch of buttons and sliders and text fields and all of that sort of stuff, lots of them. And interestingly enough, this one also, when you close the thing, it also saves a file with all of the results in. So if I open it back up again, all of the information is still there, because I wanted it to be essentially a complete standalone application. So that's what anything that says stream and input and output is all concerned with reading and writing files. And so that code is just there because when the program closes, I need to write out all of the file information. So that's what that's doing. Now, the interesting thing about any GUI code that you see is that all of the work is really done in something that's usually these days called a listener. And that just means when you hit a button or something that does something active, there's going to be a little chunk of code that you've hooked up that says go off and do this thing according to whatever information you've got. And so if we look at what happens in, for instance, when somebody hits the register button to register themselves in a Derby, all of the stuff when they click the button, the code that gets executed is right there. So in GUI code, you ignore everything except the listeners because that's where all the goodness is happening to do stuff. Okay? And so there's, what do? Oh, well, I need the name of the person, so I'll just go to the text field and I'll grab the name of the person out of the GUI component, and then look at what happens next. Make a new bucket, what we called a bucket, with the appropriate name, and add that to the Derby. So that's exactly the same code that we had in the main program. It's just now in this little tiny component area to do the work of getting people registered. So they get added to the Derby, and then this just clears out the text field back to empty, and then this refills the information in the other two panels, or the other two tabs, to get it all updated when somebody gets added. Okay, so that's how that takes place. Okay, and so there's one example of an action listener. Here's the thing that goes through all of the people in the Derby, adds their names into a list, sorts the list of names, and then calls a for each on the sorted list to replace the stuff in the combo box, the drop-down list. Okay? So you can still recognize, oh, we needed a Derby to do this, to hold on to all that information. All of this stuff is just reorganizing it and processing it for the GUI. Okay? So nothing exciting there. There's another one that does stuff. Oh, look, biggest fish. We're calling, find winner, which we wrote from the Derby, and then within that there's, oh, okay, now if there was an actual winner, we need to turn around and grab his biggest fish and add it to the appropriate fields in the GUI. Okay? So the whole point of this exercise is not to get you used to GUI code, although you're welcome to go look at it and steal it. It's just to point out that all of the things that we've been writing definitely have their place in here. You should be able to pick them out and go, oh, yeah, we've already done that. The only thing we haven't done is wrapped it in this beautiful visual thing. And with that, we're done.